Good morning, everyone. It's my great pleasure today to introduce this roundtable about in-orbit servicing. I think it's a super exciting topic here. To speak about in-orbit servicing, I'm very happy to welcome here Morgane Lucas. She is Director of Strategy and Public Affairs in Astroscale France, so you're going to tell us all about what you do in Astroscale. Followed by Alban de Crémier, is the General Manager of Lookup. And Gaël Scott. Gaël Scott is the In-Orbit Services Program Manager at the French Space Agency, CNES. So to start and to dig a little bit into this topic, we would like today to really explore what is in-orbit servicing, how it can contribute to Europe's sovereignty, space sustainability, but also action in space and dual-use application. Without further ado, I'm going to ask our panelists to introduce themselves in 1 or 2 minutes to explain what they do and what the company do. And we will start with you, Morgane.
Thank you very much, Lucy. Good morning, everyone. It's a great pleasure to be here. It's my first time at Paris Space Week. So my name is Morgane. I'm in charge of strategy and public affairs for Astroscale France. So Astroscale is an in-orbit services company. We are headquartered in Japan. We are around 13 years old. And we have subsidiary in the US, in the UK, in Israel, and the latest one in France, in Toulouse, since 2023. So we do everything around in-orbit services in both GEO and LEO. So this includes active debris removal, end of life, refueling, repairing, recycling. So everything that's around docking to a satellite and doing services afterwards.
Thank you, Morgane. And Alban, please.
Thanks. Hi, I'm Alban. I'm a GM, General Manager of Lookup. We specialize in space situational awareness, so SSA, providing radar-based tracking and advanced data fusion to monitor and secure activities in orbit. Our objective is concretely to make space operation safer, more predictable, and of course sustainable.
Thank you. And Gaël?
Good morning, everybody. Thank you for the invitation. I'm Gaël, working for CNES, so the French Space Agency. Mainly our missions are to conduct programs for the Defense Ministry, for scientific missions, and for economical development. And my activities are mainly, quite classical for an agency, unclassical topic, the in-orbit servicing. So to build programmatics, identify budgets, and make sure that our projects, in-orbit projects for in-orbit servicing are going well.
Thank you very much. And I suggest we stay with you, Gaël. My question to the audience is, how familiar are you with in-orbit servicing? Is it a topic that you know? And for that, I would like you to re-explain, in the CNES point of view, what do you count as in-orbit servicing? How do you define this technology and services?
Well, quite a difficult question. It's a blurry topic, I would say. We have 2 axes to define it. The first one is to say it's every kind of service that a satellite operator can provide to another satellite operator. A second axis is to look at the actual in-orbit services operators and see how they business take into account new services, non-classical in-orbit services, I would say, and new in-orbit services. I would end maybe with a few examples. The classical examples are in-orbit manufacturing, which is quite long-term in-orbit services. You have life extensions with recent projects and demonstrations on the topic. You have refueling in orbit, and to deal with more uncommon in-orbit services, you could also elaborate on cloud computing. You could elaborate on SSA, space surveillance. And so as you see, it's the question of having infrastructures in orbit and providing new services for the satellite operators.
Thank you very much. And building on that definition, let's go, let's make everybody dream a little bit. What are, Morgan and Alban, your key mission, your key service, your key technologies that contribute to all these fields?
Okay. So we're a bit different, but complementary, so maybe that would be interesting. So for in-orbit services, I think Gael described what we do. In Astroscale, we have 4 main services, which we can categorize in 3 categories. First, we can approach a satellite and inspect, and so come very close. We just had a mission where we went 15 meters close to a debris object that was early in 2024. So that's to inspect and characterize the environment, and we can build on ground services that Alban will describe. The second is to service, so that's global, prepared object. So an object that has a docking plate or something that we can dock on, and then we can do the services that Gael explained, and that's going to be for operational satellite, for extending their life, for managing the fleet of the satellite, for handling their end-of-life operation, and then later refueling, manufacturing if needed. And the third one is we can dock to unprepared object. So that's really tackling the sustainability aspect of this discussion, where we can dock with rocket debris or defunct satellite that were not prepared before in order to clean the environment, so like to clear the orbit and to bring them back to Earth. So 3 main categories, and for this I would summarize in 1 core technology that we called RPO, so Rendezvous Proximity Operation and Docking, RPOD. And this is all the algorithm, the sensors, and the technology that enables us to come very close to a moving object in space. I think you're all familiar with the space sector, so this is very difficult. So how we do this is we build like all the algorithm and the spacecraft to first commission. Then they worked with relative navigation. So they switched from relative navigation to absolute navigation. And they are navigating towards, with the referential, with these objects, the debris or the cooperative object. And our spacecraft can then approach to the object, perform the matching of the altitude and of the inclination, and dock safely and autonomously. I think that's 2 key words for the topic of discussion today.
That's really exciting. Alban?
Thanks. Difference, but same objective. I mean, because we also want to make space safer. And for our perspective, we develop a ground-based solution. So I mean, we bring 2 main capabilities to in-orbit services. The first one is we develop a global network of ground-based radar, which are able to track, seek, and detect almost every object in LEO, low Earth orbit, and in real time. And has the second main capability as we're gonna collect a lot of data, we're gonna analyze them, inform, and we're gonna help in-orbit services actor like Astroscale to RPO and dock, because they will need to have the best information as possible at this right moment. So you need to imagine that an object in LEO fly more than 28,000 kilometers, so it's very huge. So the time to make docking is very, very important. So thanks to company like us, the in-orbit services actor will operate, I mean, safely. So we act as a foundation, I mean, our tech as like the foundation for in-orbit services.
Thank you very much. And this being said, let's start to dig a little bit more into the geopolitical landscape. We are in Europe. There's lots of talk about sovereign access to space, sovereign capability, protect EU infrastructure. In your opinion, in the upcoming, I would say, 5 years, what are the key priorities for Europe regarding in-orbit servicing? Maybe let's start with you, Gael.
Many tricky questions. Well, I would say maybe the main goal, common goal we have is to ensure that we have the first conclusive in-orbit demonstration of in-orbit services. Clearly, in-orbit services is on the eve of being a market, but not yet a market. And we need this demonstration to ensure that satellite operators, customers, are confident that we can operate in a secure environment. So this is our common goal, whatever the countries, I would say. Then we have maybe two difficult topics to deal with. The first one is a budgetary one. For sure, some of the technologies are expensive to develop, and we all know the budgetary constraints we are facing, and we need to work together to avoid as much as possible duplication. For the current times, it's quite a challenge to agree on what are the common topics, what are the topics on which we want to advance separately, and to ensure that the key technologies are mastered by our European companies. Well, we are quite proud at French level to have companies that have done in-orbit services for years. From an institutional point of view, now we are entering business. We are very glad to have new French companies to come on the French ground, and clearly there is a virtue to cooperation.
Thank you very much. What's your point of view, Alban, Morgan, from an industrial point of view about this consolidation, I would say, of EU capacity versus free market?
Tough question. I think the main fact is everyone needs data. You need information. So for the next 5 years, I mean, the capability to have is the exact information about every object in LEO, the main objective for European capability. Because once again, and I just would like to congratulate once again what Astroscale did a few months ago. Maybe you will explain again about what you did, but that was quite amazing. And if we just back to the subject about sustainability, I think we have to protect and act for the safer space. And to do that, once again, you need to have your own data, your own capability, and you have to be able to analyze everything. So for us, and it's the work we are trying to do, is to help every European, but even worldwide satellite operators to have every information regarding that.
Marianne?
Yeah, I think for Europe, building on what you were saying, it's a mix between we need these strategic capabilities in Europe, and that's also maybe touching on the dual use aspect of this conversation. We need the autonomy of the services, and that's the autonomy of having our own assets, but also having the assets that have that can perform these operations autonomously. But we also need competitivity, because as Gaël was saying, this market is emerging. And our key ambition when we develop this technology is to drive down the cost. And only with cost driving down, and then we'll talk maybe about this later, but regulation also around in-orbit services. And obviously services that works, that are proven in space, that we can go towards the market and we can see market adoptions from our commercial client and not only institutional clients. So as Alban was saying, we are proving this technology. If you look online on Astroscale website, you'll see these pictures of a defunct spacecraft that was here 20 years ago. So that's, you know, we are advancing the technology, but at the same time, we need the regulations so from the government. So we've seen really good progress in France with the EU, with the French space law, the LOS. We are seeing progress at the European level with the EU space law. And we need these programs also to develop. So that's why we are really investing into innovation to drive down the cost. So maybe that's repeating the number of servicing we can do with one spacecraft, increasing the autonomy of the operation of the spacecraft. Right now on ADRAS-J, our spacecraft that's flying, I think we have around 50 full-time operators when we were doing the operation. So you can imagine the cost of this in 3 shifts between Japan and Europe. So we are injecting innovation and artificial intelligence, for instance, to drive up the economy and decrease the number of people we need. And then we might be able to do this operation routine. So our founder always say by 2030 we want to do routine in-orbit services as needed by commercial and institutional clients alike.
Thank you very much. If I just take some key points, I would like us to reflect a little bit. You mentioned regulation. I think it's a topic maybe for you, Gaël, and for our audience. Can you very simply re-explain what's the state of the regulation for in-orbit servicing and what's the need for the industry to enable this emerging market?
Well, the status is, in France, we have the French space law. I will not elaborate on the fact that there is an EU space law that is in discussion and we are all waiting for. About the need for regulation, I would be quite cautious. There is for sure a question of debris, and typically this is something we need to tackle on the long term. One question about the debris is that currently, the vast majority of the population of debris is for historical launches and is at the charge of the states. Then we have the question of the future debris, and this is probably something we need to work on, and this is the purpose of the space laws. And last, I would say, if we look at all this from an economical point of view, there is the need of the right regulation, not discouraging actors to invest in orbit servicing, but securing enough these operations so that they are able to do operation in a secure way and able to, I would say, split the responsibilities among actors. Typically, if we take somebody that docks to another the satellite of another actor, and then releases this satellite on another orbit for disorbiting purposes or for relocation. Then there is the question of who is responsible when and how we do transfer at what moment. And this we need to test it with demonstration and to ensure with the actors and the insurers that this is the right way.
Yeah, if I can just build on this, there's definitely the question of the liability, but there's also the economical question again, and how we can incentivize the markets through regulation. So we need to tackle the responsibility, but we also need to tackle who pays. So who pays for the legacy debris? I think that's a debate for another day. But who pays even for the commercial actors who are generating a debris? It's still unclear. They don't have always incentive to pay. So there are these rules, for instance, in the US, where they fined someone that an operator that didn't respect, but it's still marginal, and we don't know if this regulation will be enforced. And more importantly, we are thinking also at Astroscale with insurers, with operators, how to build these models so it makes sense economically for them. So they are our clients, and they also have economical problem. So for instance, how to decrease their capex and increase their opex while extending their lifetime. So maybe we're thinking at reshifting how we think about constellations, about satellite, about managing assets in space. That makes sense from a sustainability and an economical perspective, and regulation can really help with this. For instance, if we have performance bond linked to license application, that's being done in other industry, that's being done in the nuclear industry, in the power plant industry. When you get your license, you need to have a set amount of money to deorbit your asset at the end of life, and that you can unlock if you're not responsible. So that solution that can be applied maybe to the space sector, or maybe others, so we can obviously be creative. But the market is going to come through these regulations that make sense for the regulators, the actors, the operators that are generating money, and the in-orbit services providers.
I think from my point of view, the regulation and the policy have to be a chance or a good thing for operators and not bad things. My point is definitely about the regulation needs to help operators to think about how they use the space because on economic way and on a sustainable way because right now we use SAT for almost 3 or 5 years and then you change and you launch a new one. So I think it's really very important to think about how I'm going to repair my SATs when is broken, sorry, or when I'm going to refuel when fuel is empty or stuff like that. So I think it's really the regulation has to help just SAT operators think about how they need to reuse the SATs.
Thank you. And to move towards the third part of our discussion and before opening the floor for questions, I would like us to tackle a little bit military aspect, the defense aspect of in-orbit services. So a very broad question and then we can discuss and elaborate on that. What are I would say, the key objective for military purpose of in-orbit servicing? How is it different from civilian application? And in general, how this dual use, I would say, technology can be developed, as you mentioned, Gaël, in Europe in a comprehensive way without replicating all technological breaks.
Wow.
Early morning, I'm giving some energy here.
Since everything is beginning on in-orbit services, this is a large question to tackle with. I would say, first, there are 3 drivers for in-orbit services from my point of view. The first one is indeed the defense domain. And I will come back to it because this is your question and the question of the dual-use technologies. There is probably also exploration. Typically, if I'm talking about refueling, there is a need for certain missions in exploration that needs refueling. And last, and we have discussed around this, is the question of business and are in-orbit servicing able to provide some economic plus growth to satellite operators. When I'm saying this, I'm quite sure that the more solid one on the medium term is defense needs. Because we all know the growth of the different threats on this aspect, all the question of acting in space, and there is for sure an interest of military, of defense actors on the in-orbit services. Then, in-orbit services have two dimensions. The first one is the defense customers are normal customers. They have observation means, telecommunication means, so this is a classical customer. And then there is the question of, are some of the in-orbit services providing new means to act in space that are specific to military actors? And I will not elaborate a lot on these aspects, but these are different services, probably, to be managed differently, maybe by different actors, because the purpose is not a civilian, peaceful one. And by saying so, maybe the infrastructures, the corresponding satellites are different, even though the technological background is the same.
What's the point of view of Lookup?
To be honest, the space is dual use, as exactly Gaël explained. But for us, we're gonna work and help every SAT operators. I mean, so civilian and defense. So for them, it's quite the same needs, according to us. Once again, they need data, they need information, and when they're gonna dock or make some RPOs, rendezvous proximity operations, they will need to have exact information regarding the assets. So we have not the same, I mean, because they are kind of regulatory stuff and or institutional stuff, but for us, it's the even if the needs it could be different, first quite the same things.
Is it also your point of view?
Yeah, I think maybe not too different from Gail, but our technology, I was talking about RPO, docking, coming really close to an object that's unprepared. That's definitely capacity that defense agency around the world wants to have. So the core technology is the same. Obviously, the client need is different, and how we execute it is different. There's more security, confidentiality when we deal with a defense customer. I think I'd have to agree with Gail that it's definitely driving the market at the moment. For instance, in Astroscale, so we have 5 subsidiaries around the world. Each of our subsidiaries have defense contracts for defense mission. So that's including Japan, UK. Obviously, in the US, our first geo extension mission is with the US Space Force, the US Air Force, sorry. And in France, the Space Command is also very interested in this capacity to have the strategic capability to protect their assets. So that's whether to inspect, so in combination with ground, but also maybe to protect. So there's a program that's existing around this. And maybe to have an effect on something that's really also a consideration that all these companies, so Astroscale, but others, need to take a decision on, because it's, as Gail was saying, it's very different from doing commercial application. It's really this political implication, and not all of these in-orbit services company wants to do so. On the contrary, we've seen many, especially in the US, that are shifting from commercial applications to complete defense focus. And that's, I've seen, I think, in the past 2 years, a big shift. And we were just discussing also in Brussels last week in the European Space Conference, big shift also from commercial discussion of in-orbit servicing to defense strategic capability. So maybe we're all coming back to your question to Europe, that I think it's important to have this strategic capacity, whether they have civil, commercial, or dual use, so defense application for Europe and for France, because we have the capacity to have them with our current actors in France. I think we're a big space nation. And then how this will develop, we'll have to see with the threats.
I think that's almost conclude our discussion, and we'll have time for question. Is there any last key message that you would like to pass?
Maybe a short sentence, because you opened the door to the first question of our discussion. Yes, indeed, since defense uses are growing for in-orbit services, it requires us in Europe to be clear on what we want to build together, and even on the defense domain, and what we need to develop separately.
Thank you.
Just for us, I think in-orbit services is kind of the future of space, even if we have Moon or Mars project, but in LEO, close to the Earth. And I think everyone, or every operators or ground operators like us, have to work on that, and to think about differently how we're going to use the space, and to stay sustainable. So let's do it.
Morgan?
Yeah, exactly along the same line. It's going to happen, whether we're here as agency, as space actors or not. Space, in-orbit services, they are coming. So the question, I think, for France, for Europe, and for us as an in-orbit service actor is, do we want to be a part of it? Do we want to be just a footnote? Do we want to be the main leaders in the domain? That's the question we are asking ourselves every day, and hopefully we'll find the answer.
Thank you very much. I hope we have a little bit of time for question. I think I'm going to be the MC because we are lacking a microphone. Is there any question here? Or Brieux, if you can.
So every year there are more and more satellites launched, especially nano-satellite lately, with thousands of them. And we hear that there is more and more waste in space, which become dangerous to launch spacecraft and so on. So in your opinion, who should be responsible to clean space? Should there be a worldwide regulation for this? And who should pay the cost at the end of the day?
Well, your question is probably linked to some point we discussed, but only too lightly at the very beginning. This is why we are moving forward on the space laws. We try not to move too quickly on this path because we do not want to make all these markets collapse. Second point, we want to ensure that the law can be applied, can be followed, and that we have the necessary technologies for the satellite operators to use them and be compliant with the law. Then, this means, because this is a growing concern, as you raised it, that we are working both on the technological aspects and on this regulation. At French level, we have issued a new version of the space law, taking into account specifically in-orbit services. And at some stage, we will probably ask actors sending nanosatellites to respect a certain level of sustainability constraints, either by design or because they have contracted with an in-orbit services operator to ensure that they will clean the orbits. Yes, I think this is the main elements. I don't know if you want to complement.
No, I think it's what you were saying. So I think you're talking about there's two sides. So Gail was saying about the future objects that we can regulate, we can prepare, and hopefully enforce. And hopefully we are here to service them if they need. But then you might be talking about the ones that are already in space. So we know there's like 36,000 debris more than 10 centimeters. So there's a few sides to this. First, we can't capture small debris. I think at least we can't. I don't know if companies can, but like there's been experimentation with like nets or other kinds of technology. I don't think that works yet, and I don't think all the you can correct me. All the SSA providers can see below 10 centimeters very clearly. Not yet, yeah. So we might be able to see, and then we'll see how we can maybe capture this. So for us, we focus on big debris to reduce the collision risk so they don't become small debris. So we remove like a upper stage Japanese rocket that's a 2-ton object. If it collides, I don't have the number, but obviously providing millions or hundreds of millions of small pieces. So, and then the question of who pays for this. For this mission is the Japanese government that's paying for this with the Japanese Space Agency. There's another mission in the UK along these lines. But then it's a question of how much investment you put on an object that's dead is not going to provide revenue, and you put another object in space to remove it. So it's a very complex question, and maybe back to incentives, and if you have like a pot of money that they deposit as an insurance, that could serve as a fund to remove debris, but that's, I have to say, a bit idealistic on the regulation, implementation, and economic side, but we might envision something like this, yeah.
Hi Morgan, I'm Annika from Airbus Defence and Space. My question relates to what you were just actually hinting at, the fact that you are putting another object, so first of all the launcher and then your spacecraft into orbit in order to remove debris. Is the, let's say, sort of the net impact on space debris already positive? Or, I mean, I know you need some time to get there, but is it already positive, or are you still working on that?
Yeah, that's a very good question. And that's why I was talking earlier in my conversation about driving innovation to have the maximum number of servicing per object, exactly to reduce this, and also increase the capability of our spacecraft. So right now our 2 objects in space are demonstration. So the first one was a rotor, so maybe the rocket we don't count, but it's deorbiting itself. The first rule we have obviously is not to create more debris. So all of our objects have redundancy and have the capacity at the end of their lives to come back and to deorbit themselves. That was for the first one. The second one is going to do the same, currently deorbiting, but they're demonstrations. So maybe as Gail was saying, we're not yet in the market and sustainability perspective. For the future, the goal is to do, for instance, with our end-of-life servicer, to do 1 for at least 3. So maybe you can calculate the impact like this, but also it's about when we're removing an end-of-life satellite with this, our satellite, we're decluttering an orbit, for instance, like OneWeb or like a constellation. So we're like decreasing the risk in this specific orbit that's really congested, and then coming back to Earth. So that's how we provide the value also, and that's also the economic value to the operator, to not lose their slot if they have a max functioning satellite, a defunct satellite in their operational orbit in a constellation, really high or for a long time. That's going to pose more debris and more risk to these assets than sending 1. But the goal is really to do not 1 for 1, to do 1 for 2, 1 for 3 more. And obviously there's other technologies that exist to prepare, for instance, the upper stage of the rocket, to prepare the satellites so themselves can be refuel, repair. But there's always the economic of launching, this fuel and launching these satellites. So, yeah, there's a lot to work on. But right now, the goal, I think, is to decrease the risk that these debris and these assets are posing when they're defunct in space. That's one side. And then to increase the capacity we have, if we talk about the defense, and to increase the economic equation of the operators and of the clients. Lots to work on, but
and maybe if I may, just what you are describing is one of the very revolutions promised by in-orbit services, which is to move from a space with disposable assets to a space where assets are used several times. And it applies to in-orbit services as well.
Yeah, actually you're saying it better than I did, but you see the value chain of spacecraft or cars. So you manufacture them, you build them, you operate them like spacecraft. But then at the end, if you're breaking your car on the road, you're going to repair it or refuel it or move it, right? And with satellites, we just leave it here. So the promise of in-orbit servicing is to build this last value of the satellite chain, exactly for this, for the circular economy and for the sustainability and the efficiency. So to repair, to upgrade, to recycle, and not to leave this defunct satellite on the slot, like on the highway, so they would pile up on each other, and that doesn't make any sense sustainably and economically. So, yeah, thank you for summarizing.
Last call, is there any other questions? 1, 2, 3? I think it's the time to wrap up. Thank you very much for your time. Thank you for all this discussion. I think it was really interesting. And with that, we will leave the floor to the next roundtable. Thank you.